Hello everyone. So I messed up the directions on number 30 through 32. Just cross those out. Here's what the directions should say. The directions should say what value of x would make the lines parallel, or I guess we could say, let me zoom in a little bit. What values of x or x and y would make the lines parallel. And what you're going to see is that these already have parallel markings on them. So we're just seeing what the value of x and y would be if these lines that are marked are parallel. So I apologize, I copy pasted those wrong. So what you're going to see is we already have a set of parallel lines. This yellow line is parallel to this yellow line. Okay, so if this is our transversal, what kind of angles would these two be? These would be same side interior. Those are happening on the same side of this transversal on the inside of those yellow lines. And so those are same side interior. And so because those are same side interior, we know that x plus x minus 26 should add up to 180 degrees. So 2x is going to be equal to 206 when I add 26 to both sides. And so when I divide by 2 on both sides, I get 103. So x would have to be 103 degrees. How do we know if we did that right? Because if you went back and plugged that in, this would be 103. And then the other angle would be 103 minus 26. That is going to give me, when I check that, just making sure, 103 minus 26 gives me 77. And then, of course, 77 plus 103 is, in fact, 180. So those were same side interior angles. All right, again, if we know that these yellow lines are parallel, there's my triangles that mark those as parallel, and then this angle is pointing to this corner, and then x plus 55 is pointing to this corner. So what kind of angles are those? Those are corresponding angles. What do we know about corresponding angles? They should be congruent. 3x minus 5 is going to be equal to x plus 55. And so we can tell as well because those are the same size. And so we're going to subtract 1x from both sides, and we're going to get 2x minus 5 equals 55. We're going to add 5 to both sides and get 2x equals 60. And so x is going to be 30. 30 is that magic number that because those are parallel lines, x has to be 30. X has to be 30. 2x equals 60. If we went back and plugged that in, we'd get 85 on one angle. We'd get 3 times 30 is 90. 90 minus 5 is also 85. So I know that I found the correct value because those are both acute angles, a little bit less than 90, so 85 would make sense for both of those. So you can check yourself before you wreck yourself on these problems. Now, we do have a set of lines here that are parallel, but then we have something happening is we have two different transversals. I know that because these are not parallel. So this pink line is going to be a different transversal than this blue line, okay? And so let's just look at it like two separate problems. Ignore the blue line. What kind of angles are the two ones around x? Well, these are going to be linear pairs. That's pointing to here, and that's pointing to here. What do we know about a linear pair? We know that a linear pair on those pink lines should add up to 180. So I'm going to do x plus 20 plus x plus 10 should have a sum of 180 degrees. And so then 2x plus 30 equals 180. So 2x equals 150. And so x should be 75. X is going to be 75 if those lines are parallel around the pink transversal. Well, let's look at the blue transversal now. We have y, and then we have, this one's interesting. We have y here, and then we have a line, I'm sorry, we have an arrow pointing to this set, which is y minus 40. Well, y'all, that is not a one of our 5 pairs. It's not corresponding because that's top left, top right. It's not alternate interior, alternate exterior, same side interior, same side exterior, because one is exterior, one is interior. But what can I do? I do know that if these lines, these yellow ones, are parallel, then I can copy that y minus 40 to be right here as well, because those are corresponding angles. So y minus 40 would be here and here. And now what do I know about y minus 40 and y? I know that together, those make a linear pair. And so together, those should add up. Let's see if I can change colors. Those should add up to 180 degrees. So I know that y minus 40 plus y should have a sum of 180 degrees. So we're going to add our y's together, combine like terms. 2y minus 40 equals 180. So 2y equals 220. So what should y be? Y should be 110. So y is 110, and then x is 75. So we could work this almost like two separate problems. And we know that that is right because if I plug that back in, 110 minus 40 gives me 70 degrees. If that's 70, then it should be supplementary to the other one, which is 110. So I know that I did that right. All right, which line or segments are parallel based on what's given? So we talk about like this in my class. We can tell it's either going to be D and E are parallel or S and T are parallel just by looking at it. But we can't assume. We have to have the markings that are necessary. And so in my class, we call these, if we have numbers there, we like look at what is written. If we have the arc marks, we kind of think of that like friendship bracelets. This is saying that these are twins. And so who is our transversal? Our transversal is T. What lines is T going through? It's intersecting D and E right here and right here. And so we can say that D must be parallel to E. How do you know that? That is going to be because those are converse of corresponding angles. Those are in the same corner, top right and top right. And so those are in the same corner. Those must be, those are congruent because they're marked as congruent. So boom, parallel is what we say in my class. Again, here it's either going to be AB and DC or AD and BC, but we need to find what is actually marked. So here are my angles. What is my transversal going through those angles? Line D. So what lines become parallel? AB and DC. So we're going to say that line AB is parallel to DC. How do we know? Well, what kind of angles are those, my friends? That's going to be the converse of, what are those? Alternate, not exterior, interior, because that's inside of those pink lines, angles theorem. So because the alternate interior angles are congruent, boom, those lines must be parallel. So it's going to be a converse theorem. All right, this next one, we can already tell it's either going to be RP is parallel to SQ or NT is parallel to OU or none of the above because we obviously have some intersection points. So let's find what we have. We have these marked as congruent. So what's my transversal? My transversal is this line. What lines do those intersect? RP and SQ. So we're going to say that RP, based on what's given, is going to be parallel to SQ. Why? What kind of angles are those? Because that is the converse of alternate exterior angles. Because those are congruent, then boom, those must be parallel. So again, that's a converse theorem because I'm proving two lines parallel. All right, again, here we can make a pretty good guess because we only have two sets that happen to look parallel, but we need to justify it with a reason. What is my transversal that goes through both? That is going to be line G. What are the two lines that get intersected? Well, that's going to be U and T. So U is going to be parallel to T because that is one of our core 5. So that's going to be the converse of alternate exterior angles theorem. Those two angles were the alternate exterior, and so if those are congruent to each other, then boom, those lines must be parallel.